Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen. So welcome everyone, ladies and gentlemen. Good morning, good afternoon, good evening, depending where you're joining from. My name is Belén Gallego. I'm going to be your moderator today. I'm part of the ATA Insights team, and I'm based here in Spain. So for me, it's more like the evening, although I think that people are joining pretty much from everywhere. So welcome everyone. And today we're going to be talking about storage for Hawaii, a model in technological innovation for high renewable penetration. It's a very interesting case study, always Hawaii. And with us today, we have 3 experts that are going to be giving us key information that I think you're really going to appreciate, and you know, tips that you can probably take into your business model right away, into your company right away. So I'd like to ask them to introduce themselves. So in case you don't know them, you will get to know them today. So I'd like to ask first, please, David, if you can introduce yourself.
Yes, hello everybody. David Millar. I'm the Director of Resources Planning Consulting at Ascend Analytics. So I'm mostly focused on using analytics to do long-term resource plans and resource valuations for utilities. And we're going to talk about our work for Hawaii Electric to support the 2016 Power Supply Improvement Plan, and how storage figured prominently into that 100% renewables plan.
Thank you very much for being here with us today, David. Next, I'd like to ask Daniel if you can please introduce yourself.
Yes, hello everyone. This is Daniel Dedrick. I'm head of Project Technical Services at Clearway Energy Group. We're an independent power producer who we operate mainly in North America. We have projects in Hawaii which are currently operating, and also additional projects under construction. And I'm looking forward to talking through some of our experience there and how we approach that market, and looking forward to the discussion.
Excellent. Thank you very much, Daniel. And last but most certainly not least, Kate, please, if you could introduce yourself.
Thank you. Good morning, good afternoon. Kate Sherwood, the Business Director for Energy Storage here at Bartzilla North America. And if you don't know Bartzilla, we're a global provider of solutions for both the energy and marine industries. I'll share a little more later. Thank you.
Excellent. Thank you very much to the 3 of you. Okay, so let me, guys in the audience, give you a little bit about how it's going to work today for the structure. We're going to have 3 short presentations, around 10 minutes, perhaps a little bit more. That should take us like about 30 minutes, more or less. And then we have a little bit of like a conversation between the 4 of us, you know, with some questions for our speakers. And then we have like 15 minutes for questions that you sent. So that means that you have to send the questions, guys. So let me tell you, you have the chat where you have been so kindly introducing yourselves. We always love to see where people are from. And it always amazes me how people really like this topic so much. They're well into their night, you know, they're there, they're present, and they're paying attention. So thank you very much. I've seen there are people even from Egypt. It can't be early in Egypt right now. So thank you very much for being there. Send us your questions, not through the chat because they kind of get lost and they're difficult for us to manage, but send us through the Q&A box at the bottom of the screen, okay? We'll take them there and it's very easy for us to queue them up so that we know who to answer them and whatnot. So please send them through there. And just to let you know, we are recording this session, so you will have the opportunity to watch it again, to send it to your colleagues, and you will also have the opportunity to peruse the materials that you see on screen today, okay? So we always get that question asked more than any other, and if I had $1 for each time I've been asked that question, I won't be Jeff Bezos, but almost, so just so that you all know and you're set up. Okay. So without further ado, I'd like to ask David, please, if you can set up your presentation so that we can get started. You know, please, guys in the audience, keep talking, keep those questions, you know, send your questions because you don't have to wait until the last 15 minutes. In fact, if you send them in advance, it allows to prepare a little bit. David, just take your mute of your microphone. Don't forget that because we can see your presentation just fine. Yeah, perfect.
Excellent.
Go right
Thank
ahead.
you. Okay. All right. Well, thanks for having me again. I appreciate this opportunity to talk about some of our work for Hawaii and their truly landmark resource plan, and kind of the resource plan that started them all on the 100% clean energy pathway. So I'm just going to start with the obligatory about us slide. So this is Ascend is headquartered in Boulder, Colorado. That's where I am. And we have 75 employees, but not just Boulder, nationwide. And we're a software and services company with a focus on advanced analytics to support the power industry, and particularly in the valuation and operations space. So what we used for the Hawaii resource plan was this product called Power Sim Planner. So this is our production cost model that goes into 20, 30, 40 years in the future, and does optimal capacity expansion. So choosing what resources should be added to minimize cost while also achieving environmental objectives like 100% renewables or clean energy. We also have software around the optimization and bidding of energy storage. It's called Smart Bidder, and the valuation of storage projects, which is called Battery Sim. And also the Ascend Market Intelligence is our long-term fundamental forecasts of power prices, power price dynamics, including day ahead and real-time prices, ancillary services prices, capacity prices, and so on. And you can see kind of our logo slide, work with utilities, developers, finance, community, so all over the energy industry, and helping facilitate smart transactions and good valuations. So Hawaii, so this is work that is actually getting to be a little bit older now. We did this work in 2015, 2016. This is for the 2016 Power Supply Improvement Plan, aka their 100% renewables resource plan. This was a plan that they've been trying to pass for several years prior. It had been rejected at the commission level twice prior to this third and final effort, which Ascend participated in. And what we were able to figure out was actually how to get from 100% by 2050 to 100% by 2045, and able to figure out an optimal portfolio that included 10,000 megawatt hours of storage. So if you assume those are like 4-hour batteries, that's 2,500 megawatts of 4-hour storage. Keeping in mind that the peak load of Oahu is only 1,200 megawatts. So you can see that this was actually a large amount of build out of storage in order to incorporate a large amount of renewable resources. But we also looked at what is the contribution of storage and flexible thermal to support the power system and able to provide flexible capacity. And at the time, this was sort of not well understood. It's better understood now, but that we're moving from a power system in which there's something like a base load and resources that kind of run all the time, and you don't need that much flexibility because power supply is all dispatchable, to one in which most of the energy is provided by renewable resources, which are fueled by meteorology or weather. And it's intermittent, it's variable, and so we need a highly flexible dispatchable fleet in order to be able to accommodate and integrate those renewables. So we looked at what's the optimal balance between flexible thermal and battery storage. How do we minimize the amount of renewable curtailment and be able to shift that energy from times when it's not needed to times when it is needed. And then make sure, of course, that we have resource adequacy, not just in normal average days, but when there's wind droughts for weeks on end, when you have a lot of cloudy days. People don't necessarily realize that Hawaii can be quite cloudy, and you don't have enough energy, and so you need to have a large amount of resources that can activate in those types of situations. So it's a long, fairly complex resource plan. I'll put a link to the resource plan in the chat once I'm done. If folks want to have a look at that more closely. But this is just showing the energy component of the resource plan. And so you can see it's going from thermal gen in brown, squeezing that out over time, but not entirely squeezing it out even in 2045. And that's really for integration reasons, and for the fact that you do have certain periods in which there's just not going to be enough renewable generation to support the load. But a fairly even split between solar and wind. You can see that the dark shade is onshore wind, so Hawaii actually doesn't have a lot of potential for onshore wind. But the offshore wind potential is huge, and ultimately, if they're going to balance the amount of solar that they're adding with wind, that we see that as needing to come from essentially floating platforms of large offshore wind turbines. And then on the solar side, a fairly even split between customer-sided solar and utility scale solar. So, and part of this is, again, we're talking about 2,500 megawatts of battery storage, but even that much storage isn't enough to completely eliminate the need for dispatchable resources, so flexible thermal resources. This is a dispatch chart, which is January 2045. So this is when you're going to have the most issues, right? When it's January, it's still Hawaii, so the seasonal variation isn't that much, but still it's cloudy, and you get situations which you're just not getting enough sun, and you're not getting enough wind. And in this case, what this little black line you're seeing here is thermal gen, and you see most of the time, in fact, it's basically sitting at zero, so it's not doing anything. The wind and solar is carrying the load, but there are little blips. You can see when the batteries are depleted, and that's what you can see in the bottom, in the negative side of this graph here is batteries being totally discharged, and then still, particularly at night, when there's obviously no sun, that you need some thermal to come on and pick up the slack. And so what we had to communicate at the time is that you actually need to be investing in your thermal fleet to make it more flexible, because a flexible fleet is one that can just sit here in zero and then turn on at a moment's notice. So no minimum run times, essentially up from cold to full power in less than 10 minutes. So these are services that internal combustion engines in particular are excellent at providing, and to provide this critical reliability service and renewable backup. So batteries, this is like kind of a trope at this point, but it's a Swiss Army knife of resources. And we know that batteries do a lot of amazing things for the power system. They don't solve every problem, obviously. And the ones that we think about today that they provide is clearly ancillary services, regulation up and down, frequency response, and then peaking capacity. So how do we manage the head of the duck, right, and charge and discharge into those early evening hours. But there are many services that can provide. When we look at batteries, we need to be able to stack all of these value streams and understand how can batteries be dispatched in order to achieve and maximize all these different value streams that we need. And that's really what we're doing today is figuring out how to use these incredible assets. And then as we look ahead to what does it take to make a 100% clean energy system, I really see 4 core components. One is you have to create clean energy, and storage is obviously doesn't make energy; it moves it around. But we have to create a lot of energy. We have to manage short-term supply and demand imbalances. And so that's more like services you need on the minute lead to a few hours time scale. And then we need what we call clean firm for reliability. So this is resources that don't have any duration limits. So storage, obviously, it can get discharged. And so we do need some amount of resources that we can count on and we can dispatch that have clean fuels and no weather dependency. And then managing long-term supply demand imbalances, that might be things like moving energy from spring to summer, so seasonal, long-term energy storage. And so most of the things on the left side of the screen we have now, and we're adding to the system, including winds, solar. Obviously, those are key for Hawaii. Geothermal as well. There's geothermal projects going on in Hawaii. Bio resources, and then from the short term kind of supply and demand imbalances, we have storage, 8 hours or less, and then there's either traditional demand response or more advanced demand response like smart thermostats, smart water heaters, dynamic pricing, very important, potentially some vehicle degraded types of applications in the future. And on the innovation challenge, so what we don't have today that is where everyone is working on is that very ultra long duration storage. So that might be things like iron air, flow batteries, cryo storage, gravity, hydrogen, pump storage, compressed air, stuff that is will definitely be a much more important need as you get to higher and higher renewable penetrations. But that is definitely in the future. And then, of course, for clean, firm reliability, we have today we have gas-fired generation. In the future, that's going to be something either using renewable fuels or potentially some carbon capture. But that is these are all things that need to work together in harmony in order to make this 100% clean energy system work. That's where I'll just leave it for now, and look forward to folks' questions.
Thank you very much, David. Thank you very much for your presentation. And there are a couple of questions, but we'll take, if you like them after, or you can also, answer them by text if you prefer. And I'd like to ask Daniel now to please share your screen and start your presentation.
Great.
Thank you very much. Go right away.
Excellent. Yeah, thanks. Thanks, David. Really enjoyed that presentation, and yeah, good to chat with everyone here. I get to talk a little bit about what happened after the resource planning process here, and I'm going to chat a little bit about some of the projects which are currently being built in Hawaii that we at Clearway have the privilege of being a part of and leading. First, before I go into that, though, I'll just talk a little bit about Clearway as an organization. So we're one of the larger developers and independent power producers within North America, and we have essentially just over 5 gigawatts of operating wind and solar assets currently, and of course a lot of projects in development with a 15 gigawatt pipeline of wind, solar, and storage assets. So we're a major player in this market. We really focus on making sure that clean, reliable energy is available to all of our customers, and Hawaii is obviously a big market for us in terms of how we see the needs for additional solar and renewables and storage within that market. So we're a fairly significant size organization. Currently we have about 600 employees. We're headquartered actually in San Francisco, California, but we have 5 main offices across the United States. And you can see a lot of us in various places, from Houston to Arizona to New York, and I actually live in the Pacific Northwest. So we're well spread out across the United States with those locations as being our main headquarters. We have a decent number of operating solar sites. So of that 5 gigawatts, there's about 350 solar and wind sites operating, and we have a growing amount of storage assets, which I'll talk about in a minute. So we have 4 main business areas that we focus on. The first is utility wind, and in utility wind, we have probably the most capacity currently right now. That's about 3.5 gigawatts of assets across 13 states. And then we have another 6 gigawatts, which is currently in development across various parts of North America. Second area is utility scale solar. So this is also our kind of part of our larger business units. We have 26 utility scale projects. These are projects that are 50, 100, 200 megawatts. Kind of a typical project for us nowadays is about 200 megawatts, a fairly large scale. So we have a total of 1.3 gigawatts of those types of assets operating, and then an additional 5 gigawatts under active development currently. We've also done quite a bit of work in community solar. So community solar is something which is, well, some people call small utility. So these are sites that are, perhaps a couple of megawatts up to several megawatts. And we actually are, basically providing energy to individual customers from those community solar projects. And what's interesting about those projects is that's where a lot of our storage first became important and part of our business. And so a lot of our initial solar and storage assets were developed in 2018 and 2019. For those community solar projects. So that was a growth storage market for us also. Increasingly, we're doing a lot more energy storage, like a lot of developers in North America. So, as I mentioned before, we have about 30 smart Massachusetts projects which have storage on them, and we are now have quite a bit of storage in construction, both in Hawaii. There's about 300 megawatt hours in construction currently, which I'll talk about. And then also we started construction on some very large facilities in California with over 450 megawatts of storage at various facilities within Southern California. Increasingly, historically speaking, we've seen most of our storage be attached or co-located to solar facilities, but increasingly also we are starting to develop more standalone storage, and that's relevant for markets like Hawaii, but also other markets in the North America, for example, ERCOT, the Texas region, and in CAISO or California. So just talking a little bit more about energy storage, it's what I characterize as our largest, our fastest growth business vertical. As I mentioned before, we've started, at the smaller scale a few years back, but are now developing gigawatt hour facilities, both in CAISO. In Hawaii, it's become really important, for us to add storage to our PV facilities, our solar facilities that we're developing, for those reasons that David articulated. So as you think about trying to manage a situation where more and more solar and wind penetrations are achieved, there becomes a significant need to add or attach storage to these solar facilities, especially, so that you're able to adjust and shift load as appropriate. So I'll talk a little bit more about that in terms of what we're doing in Hawaii. We actually have solar sites that we're currently operating, solar-only sites that we're currently operating in Hawaii. And there's just over about 100 megawatts of those sites which are currently in operation. After those sites were deployed, and as a result of some of the resource planning that was done in Hawaii, HECO began procuring solar and storage primarily as part of those major capacity additions. And so we're really happy to have been able to start construction on 2 significant projects on the island of Oahu this year. The projects are called Mililani and Waiava. And the 2 of those projects have a total of 75 megawatts of solar, of renewable solar, in addition to 75 megawatts of 4-hour batteries, lithium-ion batteries attached to those projects. And these projects are going to be, some of the first truly hybrid projects that are deployed for HECO's operation, and will be a big part of helping Hawaii achieve the goals for renewables on those islands. We're pretty excited. We actually have equipment being delivered to the sites currently, so construction is going well, and we will be bringing these projects online in the next year, in 2022, and bringing them into full commercial operations. We basically designed these facilities to, provide dispatchable solar for at least 20 years. So these have been designed essentially to provide that sort of service to HECO for 20 years and potentially beyond. So at that, I think I'll pass it over back to the moderator.
Excellent. Thank you very much, Daniel. Interesting projects. We will discuss further a little bit later on. And I'd like to ask Kate to please share your screen and begin your presentation too.
Yes, absolutely. And while I'm bringing the screen up, Daniel mentioned something about dispatchable solar. I started my energy career in the solar industry almost 2 decades ago. But when I started, I used to joke that really big solar needs really big batteries. And it's such a pleasure to be here today with fellow panelists that are making really big solar and really big batteries a reality. What was a joke 20 years ago is reality today. It's a pleasure. So thank you for having me. But at Bartzilla, I'll talk a little bit about who we are, what we do, and how we see Hawaii and how storage can support Hawaii's grid or grids as their individual islands. Are you able to see the screen, I hope, Bailyn?
Yes, perfectly. So go right ahead.
Wonderful.
Yes. And we can hear you well too.
Thank you. So for those of you that don't know about Bartzilla, we're a global provider and leader in sustainable solutions for marine and energy markets. We are fully committed towards leading the transition towards 100% renewable energy. So really big solar needs really big batteries. I'll talk a little bit about what we do about the storage and optimization technology, including our GEMS digital energy platform that allows us to provide balancing power plants, hybrid and life cycle solutions. We've got over 74 gigawatts, a much higher number now of installed operating energy storage capacity. And when I think about why I joined Bartzilla, today is my 1-year anniversary, we are committed towards or providing a path towards 100% renewables. Daniel and David both spoke about renewables first. After that, we actually see that, and I'll share how Hawaii needs thermal balancing and storage. David's slides, you remember that gray line I think Dave talked about that had a few blips. You still need some thermal for now. You can then phase out your inflexible plants, convert to sustainable fuels. There are future fuels, hydrogen, ammonia, lots of different combination fuels that are renewable themselves. And then finally phase out those fossil fuels completely. But let's talk about the island nation of Hawaii. It is possible to run on 100% renewables. We have done a study. There's lots more information at the link in the bottom right, or if someone wants to Google the atlas of 100% renewable energy. We have a map of the world, Hawaii as a state in the US, how Hawaii could run on 100% renewables. You can see here solar would be 81%. David mentioned wind sometimes blows at night, would be 12%, 1% hydro, a little bit of flexible gas, 3% other, perhaps that's wave technology, and then 40% energy storage. And how would that work? In the daytime, the renewables, the solar and the wind are powering the grid. They're powering the island of Oahu, Honolulu, the major cities on the islands. There is some power to X conversion and some flexible gas, but really the renewables are doing the bulk of the powering of the island or islands. At nighttime, the batteries are fully charged, and really this shifts to the batteries as the primary, I'll say, fuel source. The fuel, of course, was the sunshine or the wind, but at nighttime, the batteries are discharging unless there's a strong wind event, but that's not always the case in Hawaii, in all locations that they need it on the islands. How does that actually work? With Bartzilla, we actually have this GEMS digital platform that connects the assets, the solar power, the solar panels, the wind turbines, the flexible gas engines to the energy markets, in this case, the HECO or the local island grids. This allows the flexibility to provide whatever is in the mix of generating capacity today to be matched exactly with the needs of the islands at the time and the location that they're required. Our suite, in our suite, we have both a site controller, a fleet director, and we do have solutions for markets, although Hawaii is as an island nation, it's its own market. Some quick examples of where we've done this. In Honduras, we've provided spinning reserve, frequency regulation, and black start for the Roatan Electric Company off the coast. And again, 500 megawatts of power capacity with 10 megawatts of energy storage is providing the necessary solutions for not only the base load, again, remember the black or gray line on David's slides, but also the black start capacity and virtual spinning reserve. In another island example, the US Virgin Islands, we have a dual fuel hybrid power plant. GEMS actually takes weather forecast data from the solar and the wind forecasts and the load data for the specific islands, and actually is able to dispatch up to 65 megawatts on St. Thomas, the peak load capacity. Again, there's not only the batteries, 9 megawatt, 18 megawatt hours, but also the Bartzilla engine, dual fuel power engine, dual fuel engine using both LPG and light fuel oil as the fuel sources. And then finally in Portugal, again, Graciosa, the renewable energy consumption is 100%, and again, powered by the GEMS technology. You can see a megawatt of solar, 4.5 of wind, and 6 megawatts for about a half-hour battery of energy storage on off the island, in the Azores off Portugal. So that's the end of the primary presentation. I'll mention briefly that I live in Texas. If anyone wants a comparison of Hawaii to Texas, I'm happy to provide that, but it's much more interesting thinking about the islands. So with that, I'll pass it back to you and to the questions.
Thank you very much, Kate. It's certainly interesting to talk about Texas as well, because it's like also a grid island, right? Not exactly an island, but
Different. It depends on who you talk to. That's right.
for sure. Okay, I'm going to ask you to stop sharing that presentation, please, so that we can launch a little bit into the questions. We had prepared a little bit of a discussion, as we told you. So I'm going to just launch, I have like 2 questions per speaker. And most of the questions that you've sent, actually not most, every single one of them has been answered by text by the speakers. So I'm going to have to ask you guys to send some more. Whilst we're talking, I think you're going to have time. I think by looking at the time, I think we're going to have maybe 5 to 10 minutes, so maybe we can answer 2, 3. So please send them. Okay, so Kate, I'm going to start with you, if I may, since you've just been talking. And question is kind of like open, but also gives you an opportunity to, choose how you want to answer it. It's about the renewable penetration goals. How do you see the future of renewable integration in Hawaii and beyond? Perhaps, we can take the learnings from the islands, maybe into mainland, something here. So.
It's a great question. Let me answer it in 3 parts. First, Hawaii, the operators of the Hawaiian grid, I think, recognized their challenges at least a decade ago, if not 2 or more. And as a result, their recognition of their unique island issues has allowed them to be a leader in choosing to install renewable energy, again, solar and wind, a variety of different technologies, and now energy storage with folks like Daniel and Clearway. I think that recognition that I'll say they couldn't survive on diesel alone, that was a bad choice for them, for their economy and for their residents and their fragile ecosystem, their natural ecosystem. That again, it was a long time ago that they came to that realization and started down the path. I think that what we can, sorry, the question was, what about Hawaii and what can we learn from it, correct? I think that other grids can learn a lot, first off about the technology. How does solar and wind interact with Daniel's battery, 75 megawatts of solar and batteries together? How does that interact? How does that support the grid on a true technical level? To switch briefly to Texas, I lived through the snowvid in February of this year, where I lost power for 4 days and it was awfully cold. And Hawaii, maybe only the mountains of Maui might be the only places that have that in Hawaii, but they had resolved some of the true grid issues. When ERCOT went into crisis, the frequency on the grid almost reached crisis levels where it was below 59 point. It was very close to the minimum required of the frequency. The frequency of the electrons passing through the grid was almost to shut down. And again, Hawaii, because of their unique ecosystem, the way they get typhoons and all sorts of weather events. They get VOG from active volcanoes. So they've dealt with a lot of the issues already that I think grids like ERCOT can learn from. The scale is a question. Implementing something on Oahu has geographic challenges. And then in a scale like ERCOT, it would have size or scale challenges. So that's I think the answer.
Yeah, the answer was really interesting. So I'll let you continue. The original question was the future of renewable integration. I don't know if you want to talk about other gases that you mentioned in there as well, because you mentioned several gases, right? Like or new chemistries that could be used in a renewable setting.
Sure. So in power plants, again, Bartzilla is leading some efforts around not just using traditional fossil fuels, but also future fuels such as hydrogen, methanol, ammonia, other renewable gases, renewable physical fuels. But I'll go back to that 5-step process that I shared that Bartzilla believes in. No customer can, I'll say, flip a switch overnight, or that perhaps would not be the lowest risk path. We do fundamentally believe what I call crawl, walk, run. Hawaii is probably walking, if not running already, with power plants like what Daniel's brought to market. But each grid has to implement a little bit at a time. first put some renewables on the grid, then think about how you phase out inefficient baseload plants, then and add storage. Have a path and a decision process to move not overnight to 100% renewables.
Yep. Thank you very much. And the next question that I have for you, as Hawaii is an island grid, what types of energy storage solutions are developed to assist these grids, and how is Bartzilla specifically supporting these grids? Which you kind of answered, but more specifically.
Sure. I don't want to feel like I'm speaking a lot, but we have battery, traditional financeable battery energy storage systems and our GEMS digital energy platform. Combine that with our flexible fuel power plants to support Hawaii specifically, and I'll say island nations transition from traditional fuels to future fuels. Actually, I'd love to turn this to Daniel because and get his opinion as well. Hawaii has thought about a lot of different types of technology. And again, you have in your projects gone to, I'll say, the financeable projects, the financeable technologies. Anything to add there, Daniel?
Yeah, for sure. I mean, I think in terms of what can make a really big impact in the short term are these sorts of hybrid facilities where you couple solar generation with lithium ion, like 4 or 5 or longer duration lithium ion. There's been a lot of success in the market of being able to move those types of technologies forward, and it's really been an enabler for grid operators like HECO to be able to see a pathway towards quite a bit of progress on their goals for renewables integration. So I think that'll carry us for quite a ways. We are going to have to come up with some very innovative ways of kind of continuing to progress in those objectives. And so I think David brought up a couple things like very long duration storage. Perhaps that's a solution that'll help us kind of get over the hump, or perhaps synthetic fuels become important. I think those will continue to be viable, but we still have a lot of capacity that we need to deploy in this sort of 4 to 8 hour lithium ion, and it'll help us make a lot of progress in the next 5 years, for example.
Yeah, thank you very much, Daniel. This is a good point that you guys are making here. Yeah, there's a lot of like little blocks that we need, but first we need to focus on the big blocks that are still ongoing, so to speak. So I have a couple of questions now for you. So thank you, Kate, because you've given me an easy way to move on to the questions for Daniel. So you mentioned your project in HECO. I wanted to ask, how does HECO use the hybrid solar and storage facilities that you are building and operating for them?
Yeah, so these facilities that we're building, they're truly hybrid facilities. So those of you that are aware of sort of the nomenclature for kind of co-location or hybrid facilities, this means that from a hybrid perspective, this means that the solar and the storage are operated in conjunction with each other. So the way we do that, rather than separate assets, the way we do that is we provide HECO with what's called an active power control interface. And through this interface, they interact with the hybrid facility. So what this interface allows them to do is, based on the information that we give them around available generation, forecast generation, available state of charge, the overall sort of state of the system, they're able to take that information, make decisions about what they need to do at that point in the grid where the facility is interconnected, and then send an active power control signal to our facility, which we then respond to. So it just gives HECO a lot of control. So we basically give them visibility into the capability and what the forecast may look like. Then they can make the decisions based on how they're operating the grid and the challenges that they see. So it's really a way of like us making sure that HECO has a truly flexible facility that they're able to solve some of their challenges. We also, this facility, because of the technology nature, it has a lot of capabilities to help sort of stabilize the grid. So things like frequency and voltage support. HECO understands the capabilities. They've provided guidance in terms of what sort of range of characteristics they're looking for. And that's also a service that these facilities will provide. That's a little bit more of an automated service, but this gives HECO that sort of understanding of how these facilities can really support their grid as it evolves over time. It's a very flexible resource.
That's awesome. I think flexibility is the key here, because the needs change so much and so fast. This is not like the grids of like 50 years ago. We're having a complete different relationship with our grids. What are the opportunities that you see for developers such as yourself, such as Clearway, to work more closely with customers in Hawaii? I'm learning that that's the correct way to say it, like HECO, to ensure renewable penetration goals are met.
Yeah, this is going to be, really important, especially as we get more and more facilities online in Hawaii. The grid's going to change. Like HECO's needs are going to change. They're going to have new things, new challenges, and they're going to have to sort of recalibrate and communicate sort of their challenges that they're seeing, so that we can help them through those. I think a perfect example of this is, when we, first developed. You can kind of think about our phase of the project. So when we first developed projects in Hawaii, these were solar only assets, and they filled their need, right? It was a renewable capacity. It was something that they needed to kind of achieve their first step in that process. Next phase, they needed batteries. They needed more flexibility. So they needed the ability to have a little bit more shape, to be able to control a facility, make decisions, to stabilize the grid, those sorts of things. And now, like, the next phase is starting to happen, where things like, black start or grid forming, those sorts of services are going to become more and more important as the grid sort of progresses and as that sort of resource plan matures. So, the important thing for sort of HECO to do with us and us to do with HECO and also us to do with our suppliers, for example, with Bartzilla, is to really make sure we understand those, kind of where the grid is going, understand what the equipment needs to do, and make sure we actually design systems that can actually do that. Because these systems are, something that you can specify, and the more clearly we understand the requirements, the more collaboratively we work with all the stakeholders, the better solution we'll have for the long-term sort of asset. And so, I really see that as being the biggest opportunity, is just having that sort of collaborative approach to, what are the challenges, how do we solve them together, and make sure that the grid operators have access to those assets as we move forward.
Excellent. Thank you very much, Daniel. Very clear in steps. So the developers in the audience, I'm sure you're making notes because the opportunities are right there. And David, just a couple of questions for you. And then, as you can see, there are 9 questions open. So feel free, Kate and Daniel, to take a look and see if there is any specific you would like to answer. We can go a little bit over time if there's like a couple of really interesting questions. And then I'll pass them along to you guys in case you want to actually answer them. So David, the resource plan was rejected by the Commission several times. How did Ascend help get the 2016 PSIP over the finish line, and how does it inform your resource planning practices for others afterward?
Yeah, thanks. I'd say paying close attention to the reliability aspects, resource adequacy, looking at how weather affects the power systems as a whole was key. So I think adding that extra layer of analysis, looking even down, if someone asked about what level are you looking at? I mean, we're really looking at the 5-minute, 1-minute level to look at how do we need to do renewable integration services, and that takes just more computing power, more higher level of analytics. So that's really what we're all about, is taking the advances and what we can do now with computing to be able to solve some of these complex questions, to look at how do power systems work in real time. And I think that's something that we've continued to do and looked at as we have done other 100% clean energy studies going forward.
Thank you very much, David. And the last question that I have for you is, your resource plan called for biofuels to cover 10% of energy and capacity. Is that still relevant today? And what other options exist for providing firm capacity during renewable energy droughts?
Thanks. Yeah, you know, at 2015, 2016, you know, hydrogen wasn't exactly on the radar. So, you know, we looked at how do you provide this clean, firm service, and that was something along the lines of retrofitting the thermal fleet to become more flexible, and then eventually using some sort of biofuel to squeeze out that last, you know, 10% of the emissions, 5% of the emissions. You know, today I'd say there are things that are in the conversation, again, like green hydrogen, or it could be power to methane. It could be very ultra long duration storage technologies. I think what it underscores is that you know, there's kind of a joke amongst resource planners is that the resource plan is essentially out of date as soon as you publish it, because technologies have changed and evolved so much, which is a new phenomenon. Power systems, nothing changed forever, and so, you know, I would encourage, you know, HECO to continue to come back and do the resource plan updates, look at what new technologies are out there. And then there's this interesting question, which some folks have alluded to in the chat around, you know, what's the role of the big grid versus the small grid, or the behind the meter kind of resources. And this is, you know, South Australia is a great example, but Hawaii is really kind of one of the best test grounds about these concepts of local generation versus the remote generation. What's the right mix there? You know, back in 2016, no one had behind the meter storage. That wasn't the thing. It was just way too expensive. Now we're looking at, you know, very high levels of behind the meter solar and folks adding storage, which could be for, you know, helping the grid, responding to price signals, but also your own sort of power system resiliency, right? For folks who are in Texas who are looking for ways to back up their home's needs in cases of emergency. And so that is something that is pretty new in terms of how the technology has changed the equation, and needs to be, you know, again, looked at in depth. What's the right balance there? I mean, I don't believe that there will ever not be a need for the big grid. I just don't think that, you know, behind the meter solar, which is, you know, fixed. It's also fixed tilt, not single axis tracking. It's you know, more expensive. It's, you know, behind the meter solar is like $3.50 a watt, and then utility scale is more like $1.50 or $1 a watt. So it's, you know, there's economic questions to be sorted out around what's the relative values of utility scale versus behind the meter. But these are all important questions that we need to work through.
I love how David is kind of answering the question and also tagging on all of the other questions that people have been sending. Thank you very much.
Trying to integrate, yeah.
Answer as many as possible in one answer. Yeah,
right.
It's awesome. You know, interestingly, I work a lot in renewable hydrogen, extensively, also with Power2X. And what's interesting to me, just a note here, if it adds value somewhere, is that when you speak to all of the oil majors that are like putting billions into hydrogen because it's kind of like, you know, a lifeline, they all talk about how unfair they think it is the fact that the governments are not opening it technologically to other options, including biofuels, how they're going single-handedly for this one solution, which is renewable hydrogen, and how kind of they complain about it. I mean, why technologically you have to go in this direction? So I wonder sometimes when we're having these conversations, whether like any other technologies that we have before is going to make a comeback before we know it, you know, and all of a sudden we'll be like biofuels everywhere. And it'll seem like, you know, why did we ever take the eye of that? It's one of those interesting things, right? We've been talking about fuel cells forever, and now, you know, they're at the front runners. So definitely, I think we have to be very vigilant because things change quickly. It needs to change quickly, and competitiveness in terms of the technology to change quickly too. So, Kate, have you picked any questions? Because we have a few minutes, so that you want to answer specifically. And I mean, unless you tell me which one it is and I read it, it's probably more efficient that you read it directly, or you tell us what the question's about, and then you give us your answer.
Thank you for asking. I'm trying to scroll through the questions now. I'm going to answer one that was pushed or was proposed for Daniel about supply chain issues affecting CODs. Perhaps we've all seen that our Christmas gifts are stuck off the Port of LA or the Port of Long Beach right now, if you're in the US. And that same bottleneck has affected deliveries, certainly into mainland US. And I guess perhaps our shipping clients are having some record profit years, but I'd like to say that we have been able to resolve these challenges. In one case, for a Texas customer, we shipped a project through the Panama Canal to the port of Charleston, South Carolina, and from there overlanded or by truck moved the product to the construction site. But to say that we haven't had any surprises or concerns would be disingenuous, but we are certainly working with our large partners to resolve them. And frankly, I'm proud to say in most cases, and I think all cases that I'm aware of, we have. But Daniel, anything to add to that?
Yeah, I was just going to say also, Kate, I mean, I think supporting that, you know, we're in kind of unprecedented supply chain territory right now. So obviously everything's rather complicated and challenging, but I think the positive way of looking at this is, especially for these Hawaii projects, we're working with Bartzilla on the supply of the batteries for those projects. And, you know, I'm really happy that we're doing that, right? We chose a really strong partner to work with us in terms of that supply, and we're going to run into challenges, but, you know, as long as you have those strong sort of relationships with your vendors, you can work through it. So I think that's like, you know, this kind of feeds into that other question of what are the, you know, one or two main challenges that we're facing in Hawaii. Well, you know, supply chain is tough in Hawaii. It's an island. It's hard to get things there. And you have to be smart about how you structure your supply chain. You choose good partners. You choose, you know, folks that are willing to work through challenges with you and deliver the project. So that's how you make it through it.
Spanner in the works here, guys. Do you expect this situation to go on for much longer? Like, we already know that the Christmas presents, you know, a little bit down, but what about next year? I don't know. Is this going to be ongoing? Are you planning for that to be ongoing now? Or
yeah, it's hard to predict the future, right? But yeah, I mean, I think, you know, the other maybe the positive way of looking at this is we're in a very strong growth phase in the industry, right? So there's a little bit of, you know, as we grow and as we deploy more renewables, there's going to be continued supply chain pressures. So I personally don't expect these to just dissipate, you know, overnight. I think it's going to take time, and we're going to have to work through it. You know, for me personally, it's just kind of a understanding that we've got some work to do in front of us.
Excellent. Thank you very much, Daniel. David, I'm going to give you the chance to pick a question, and by all means, guys, if there is another question that you want to approach, then we still can do that. But David, have you picked a question that you'd like to?
I think we've covered most of them. Maybe this one, with all examples of islands going renewable, why would all island nations go to some percentage of renewable? Is the main constraint funding or something else? From Andrew. Yeah, I mean, I think that most islands are probably looking at this already, and you look at Puerto Rico in particular is definitely looking at trying to do 100% renewable. I think there were some issue in the last hurricane about damage to solar panels. So there, you know, we do have to have hardened systems and resources that can manage and ride through extreme weather. I mean, Hawaii or Puerto Rico are no different in that respect. So, you know, we have to have a hardened system, well backed up, redundant. So, I mean, I think that the primary challenge is really just it takes time to change, and but at the end of the day, if you're looking at Hawaii or other islands, the alternative is fossil fuels, which have to be shipped there, which is generally could be oil, very expensive. Potentially LNG, but it's also very expensive. So it just makes sense to try to supply most of the energy from free fuel, which is wind and solar and geothermal and others. So it definitely makes a huge amount of sense for islands, and I think everyone's basically going in this direction.
Excellent. Thank you very much, David. Is there anything, or otherwise I'd like to ask a question? Yeah, go on, Kate.
The gentleman, I think it seems to be Tim Cook, asked about the role of virtual power plant and grid.
That's the one I was going to ask. So go right ahead.
The short answer is, and how can they be coordinated by grid management solutions such as GEMS? The short answer is they can play a fantastic and vital role. Having worked for virtual power plant firms, I'll say, assuming they show up when called upon. That's a really critical piece. And there's always, even at $9,000, when the Texas grid hit $9,000 for 4 days this winter, some power plants simply couldn't show up. Some virtual power plants made a lot of money. But assuming virtual power plants are capable of showing up, the GEMS platform can physically, or I'll say electronically, but make sure that they are physically connected and doing the right things for the grid, including forecasting when they could be necessary. So GEMS can take in the weather, the load, the expectations, and the virtual power plants themselves have to, again, be able to show up when called upon. Anything to add, Daniel or David?
Yeah, no, I agree. But they certainly have a lot of, I think, local resiliency value and are important technology going forward.
Thank you very much. Okay, guys, thank you very much for sharing with us. Thank you, David. Thank you, Daniel, and thank you, Kate, so much. I've learned a lot today. I think it's very interesting, all of these topics that we have mentioned. Very, very good point that is easy to forget. This is still a real market where you have to move things around. Yes, it's electricity, but you still have to have it and you still have to show up, as Kate very well noted. Doesn't mean that, the value of being able of the data, of knowing what is going on, how you can model it, how you could improve, optimize things is not relevant and important. I think it is very much so, especially in markets that are very, very complicated in their calculations, like the value of a battery. But I think that is a very, very good point, that in the end you have to have you have to be there and be able to put the electricity in the grid. And the $9,000 you say, you might want to consider a dynamo and moving it with your hands. Maybe it was worth it at that point. A bit like playing
5,000 going forward though. They're dropping the price. It's going to be 5,000 going forward. They're dropping the price cap.
They're dropping the price. So, but anything at that point goes on. But the other day, I was in an event in the Middle East, and one of those questions to one of the major developers, actually two of the major developers, with these humongous plants in the Middle East, we asked, what is next for solar energy, and much in line to what Kate said, that she figured 20 years ago, they were saying, what happens after there is no sun? That was the point. What's next for solar is whatever it is that is not solar. We've already done really well. We've optimized, solar energy is working great. Still, the little ways in which we're tweaking the technology and it's improving is giving us gains, step by step. The problem is the minute that you have a non-dispatchable technology, you're toast. It's not going to be very popular going forward, because increasingly so the grid is becoming a very, very precious resource that you can't just dump things and then forget about it. So it's going to become something that you need to think around. So this is no joke. This is something that if you are not yet, you really need to start thinking, because in the future there is no solar without what happens after solar. So I just wanted to leave you all, what I think is the main message here. And thank you very much, guys, for these great presentations about Hawaii and all of the, I think, the headway that has been done there. And for everyone in the audience, thank you very much as well. And we'll see you next time. Thank you. Bye.
Thank you.
Thanks all.